Since y equals e to the x and y equals ln x are inverse functions, e to the ln of x equals x, and ln of e to the x also equals x. Use the facts along with properties of exponents and logs to rewrite each expression. So first we have e to the 2 ln x. Now I know that e to the ln x cancels, but e to the 2 ln x does not cancel right away. So you need to use the property that says if you have a 2 times a log or a constant times a log, what you can do is you can move that constant as an exponent. So it can become e to the ln of x squared. So that's just a property of logs. And then e to the ln cancels and we're just left with x squared. E to the ln of root x, so that one's pretty straightforward. E to the ln of root x, e to the ln cancels, and you just get root x. Now for part C, we have ln of the square root of e to the 5x. So I will rewrite that as ln of e to the what power? And that would be 1/2 times 5x. So a square root just makes it to the 1/2 power. And then ln of e cancels, and I'm just left with 1/2 times 5 to the x. So that's just 5/2 x. And then lastly, ln of 5 e to the x. Again, ln and e to the x cancel, but only if they're basically right next to each other. So that 5 needs to be moved somehow. Now we do have a property that says you can separate logs. So if you have something inside that's being multiplied, you can separate it by doing addition. So it becomes ln of 5 plus ln e to the x. And then ln of e to the x is just x. So you end up with ln of 5 plus x. And there's really no other way to simplify that. That is the answer, ln 5 plus x.